Good morning, evening, and afternoon to everyone who's joining us. Thank you for the time today as we're kicking off our halfway point event in ThreatX's 26-day race to RSA. We have a very exciting event planned for you today as I'm joined with ThreatX co-founder and Chief Strategy Officer, Brett Settle. So Brett, if you want to hop in and say hi, feel free to.
Hey, Sid. Great to be here. Looking forward. This is going to be a fun conversation today. So let's get started.
Yeah, it's going to be great. And Brett's here to help me lead the unveiling of ThreatX's next step in the evolution of threat protection with runtime, API, and application protection. We're thrilled to announce ThreatX's runtime, API, and application protection, really the first cloud-native solution to detect and block runtime threats targeting APIs and applications. This patent-pending technology extends our threat detection, tracking, and blocking to customers' runtime environments, all without slowing down developers or requiring expertise in cloud-native applications. But of course, I'll let Brett take away the show and kind of walk us through some of the background of really why the rest of the ThreatX engineering, ThreatX leadership, and yourself think runtime protection is so important.
Yeah, thanks, Sid. And I think this started for us during the Log4j incident, and that's obviously one that I think almost anyone in the security world is well aware of. But I think we were pretty excited when this happened because our SOC was one of the first to identify the attacks as they were coming out. We were able to really address some of the initial attack vectors for Log4j, and then continue working with the customers as we rolled out the virtual patches. We dealt with some of the variants and some of the permutations that we saw coming through for Log4j. But one thing that it really raised for us was simply that most of the firewall solutions, WAF, and even API protection solutions, we're always working with HTTP request and response pairs. And what we found was, a lot of these were runtime related attacks. And, the HTTP request, while we were able to do a lot, there were certainly some limitations to what we were able to accomplish just with those comparisons. And yet for Log4j, we know there were some pretty sizable breaches that were announced, pretty sizable companies that had to deal with them. And so it just really launched internally. We'd been looking at some new technologies and other ways to gather more information. And it really kind of spurred the priority level for us to really make that investment. As we kind of go through, let me expound a little bit more on what we're talking about. As I said, virtually every WAF, API, application vendor, we're all basically working with the same set of information. The difference, I think, between what ThreatX is doing and maybe some of the other vendors is that we're really adding a lot more context. We don't just take a single transaction, but we actually start to really isolate who are the attackers. How do we actually start to build kind of an audit trail of what we see for those attackers? And then using that allows us to use a risk-based analysis to kind of minimize the false positives, but at the same time still be very accurate and kind of have a defensible position. And that includes understanding more around what they're targeting. But at the same time, as Log4j was going on and what I said before, the HTTP requests were giving us a lot of information, but we had to look sometimes longer than we would have preferred to really understand what they were targeting, what techniques they were using, how they were going about it. And along comes eBPF. And for those that don't know, eBPF is a framework. It extends kind of your ability to attach at the kernel level within a Linux environment. but more importantly, it provides the safety mechanisms that allow you to, peer into that data, see what you need to see and do it at a high performant environment. And more importantly, what this is doing is it's giving us a lot more data to look at. It helps us to have, real-time monitoring at the kernel level, seeing all the way down to the network flows, the process tables, arguments, environment variables, et cetera, but do so in a really efficient and compact design. It's low impact. When you think about this, there have been other technologies that have been out for a while, like RAAP-based products, which were deployed as agents. And the challenges were always that you had to deploy those technologies and those agents, in numerous places, and the agent maintenance really made it almost untenable to be able to deploy that technology. This has given us the ability to deploy something as a single sidecar container, and yet gives us even more visibility than what you could see with some of the traditional RAAP-based techniques. And with that improved visibility, it gives you a lot better telemetry to be able to identify what's going on. And then for ThreatX, what's always important to us is how do we take all this information, build the context that we need, and then design the rules so that we can actually enforce the blocking that's needed. And then I guess lastly, the cool thing about this is, again, going back to the deployment side, fully cloud native. And that means that it really excels when you're talking about deploying in container and microservices environments. And as we know, that's really where the industry is going. And this gives us a great opportunity to have a simplistic deployment model in that environment. If we jump to the next slide, Sid, I think, as we kind of look at this, it's again, really going into visibility that we've not been able to see before with just simple HTTP request and response. And it allows us really to attack more of the types of exploitation attempts and attacks that are going on that include things like data filtration, malware execution, or malware ingestion. And it allows us to be much more effective at not just protecting at the edge, but also allowing us to understand, hey, what are the insider threats that potentially are out there? Are we seeing certain type of exfiltrations in the outbound traffic or in the outbound processes that we're looking at? What about just generic east-west traffic and the ability to easily deploy and be able to kind of have this, what we would call both a front door protection, but also have kind of the backdoor monitoring and protection that's required so that you have a fully complete solution. And again, a lot of this has been made possible simply because we're able to take advantage of what we're seeing with the eBPF technology, the fact that we can deploy this deeper in the stack. And then ultimately, again, it gives us even an option to deploy out of band as needed for certain circumstances where that's going to make more sense. I'm not going to go into all the different things that you can protect. Just, you see the list of different types of attacks like the rootkits and the web shells and code injections. And again, it's not that those can't be detected to a certain degree, but it's really the granularity that we're able to do, the speed with which we're able to do it, and really the simplicity of the deployment that makes it all kind of come together. Now, if we go to the next slide, again, this is a short presentation we're doing today, so we're not going to go through all the details. We really want to encourage you to come out and visit us at RSA or subscribe and really follow up as we jump into some of the other webinars that will be rolling more details out as we go. But I am really proud of kind of the way the application has come together and the visibility that we're able to provide. And this is just a screenshot, but I wanted to give you kind of a sense of, there's really two primary use cases that we think about as we think about the runtime protection and how we want to go about it. The first is, hey, when something is going on and we've detected some kind of suspicious or malicious activity, granularly within even an application instance, you get the alert or you get the event notification. What we want to do is very rapidly get you down to the specifics around that particular activity. You can see the commands that were executed. You can see the arguments for those commands. You can see the environment variables that were there, IDs associated to that particular event. And then ultimately what we're doing is very similar to what we do for traditional web application and API protection. It's all about how do we do the correlation of those type of events? What is the underlying risk that we're seeing for that type of event? Is it something that needs to be blocked, or is it something that you want to do further investigation? You want to see the similar events, and you really want to be able to kind of roll this stuff up and have the visibility to make the appropriate response direction. One of the biggest challenges that we see for security products, bar none and across the board, is you can have what's called alert fatigue, in which you're getting so much information And even with the best of solutions that are, providing alerts and allowing you to see this level of detail, ultimately, you also want to see it at more of a macro level. And that's where kind of the second use case that we're really trying to highlight here is more of a catalog view. When you think about the environments and how these things are deployed, you've got your standard Kubernetes cluster. You actually could have multiple clusters that are deployed in different availability zones or different cloud providers, but ultimately you've got the cluster, you have multiple nodes within the cluster, you've got the pods that are deployed within those nodes, and then you have your containers and microservices that are kind of running underneath the covers. And while we'll see the suspicious events and we want to correlate those, we really want to organize this information very easily so that you have the broad picture to understand what the entire environment looks like, as well as the ability to quickly focus your attention on which components of that environment really represent the most risk. Where are we seeing the highest number of events? Where are we seeing particular types of rule classifications that are being triggered? How can we help the analyst really take a lot of this information and quickly start to filter that down to the things that really matter and really support kind of the evaluation and analysis perspective to determine, do we have the right responses in place, or are we seeing other patterns that need to be addressed as we go through that? So again, it's two different views that we're really focused on right now. One is certainly a bottoms up, which is for the specific events. Let's get you the information you need to see immediately and really a fine level of detail to understand those runtime type of attacks. But at the same time, we want to give you the top-down visibility so that you're able to really see it all from a broad brush. And as I said, really start to drill into what do you need to address from a triage perspective, highest priority, and then work your way down the list as you go.
And
so I think, yeah, go ahead.
Oh, I apologize. One quick question, just digging a little bit further. I think it's important to highlight because we've had a lot of conversations. We've heard a lot of folks talking about runtime protection. Yep. Could you just to make it really, really clear, what is ThreatX meaning by runtime protection versus how others are talking about it in the market?
Yeah, I guess that's a great conversation because I think when you think about the application security space and you think about, solutions that range from web application firewalls to API protection solutions that are more pure plays to some of the broad platform players that are doing web application and API protection platforms that include a bot and a DDoS solution. We each have kind of our own, understanding of the different type of attacks and how we're looking at them. And, runtime protection is not real-time blocking. And I want to make that very clear. A lot of the folks that exist within the web application firewall and web application and API protection space, WAF and WAP respectively, they have real-time blocking that's built in, but we certainly have different techniques that we utilize. I think in other spaces, you have, folks that are looking at runtime protection as more, hey, I've got the ability to identify some of these complex attacks and I have a real-time blocking mechanism. And I think we want to be very specific about those. The types of attacks that we're talking about here, again, extend back to the previous slide, which was the, web shells and, utilizing the ability through a web shell to either run malicious scripts or to face a website, something that's running in the background that's been deployed as malware. Remote access threats, the ability to actually escalate the privileges or the ability to use legitimate privileges, but then obviously use malicious techniques that are around code injections. And you can kind of go through the list of different type of attacks. Those rootkits, things of that nature, they're very difficult to detect merely by just looking at, hey, what's in an HTTP request. You really need to be able to monitor what else is going on in that application environment. Are certain containers being spawned, or are certain processes being executed that are not normal processes or were not initiated maybe by the HTTP request that you were seeing? And it's really that ability to see kind of cross-cutting across the entire environment and be able to identify, certain types of commands and certain types of things. That's really what we mean when we talk about runtime protection. Things that weren't necessarily simply initiated by the HTTP request coming through. Does that make sense? Does that help?
That helps tremendously. Thank you so much, Brett, for kind of walking through the whole landscape that I think is in a similar conversation, but to your point, meaning very different things.
Yep, very good. So again, back on, I guess on the follow-up for this, I just want to highlight that one of the other kind of powerful things about this, and I think what differentiates us a little bit from some of the RASP vendors in the past, first and foremost, is there is more information available. You're able to look at the socket level, the network layer, you're able to look at the processes, the arguments. There's a lot of information you're able to collect simply because you're seeing everything that's deployed at the kernel. But the second real important piece I think that follows on to this is what we said before. This eBPF is a capability that's been built specifically to allow this level of access to kernel level activity, but to do so in a sandbox environment, do so in a safe environment, do so in an environment that has to be validated by the kernel so that you cannot cause any kind of outages or performance interrupts. It's a simple component you build in the normal user space. And for us, we've chosen really to develop this as a sidecar container that can be simply dropped into the user space on that particular environment, and then integrate directly via the APIs, the eBPF APIs within the Kubernetes cluster. And the reason I'm bringing that up is because when I talk to different security folks out there and I talk about some of the challenges they have with some of the other tools and techniques, is when you get down to this level of visibility and you start to really want to capture this level of data so you can protect against some of these more complex attacks, it can become very complex, and it can be something that it becomes very difficult to manage from your DevOps or DevSecOps perspective. It can also be something that is going to require significant integration because it has to be deployed in so many different places across your application environment. And for a lot of customers, that means you're deploying it across a pretty complex or at least a hybrid environment of multiple different technology stacks, multiple different technology components that have to be integrated with. What we're doing with our solution here is really standardizing around leveraging the eBPF API that's at the kernel level and doing so with a simple sidecar container deployment. That allows it to be very simple to plug into virtually any of the environments that support Linux, and certainly gives you the opportunity to do so in a way that's going to be very friendly from a deployment and from a maintenance concept. It will always integrate in terms of pulling configurations, just like we do for our reverse proxy solutions. It can integrate with the cloud. It'll pull the latest and greatest threat intel feeds. It'll pull the latest configurations, as well as, if configured that way, we'll be able to share information and really do the crowdsourcing and take advantage of a lot of the same capabilities that we've always done from a ThreatX perspective, which is when those net new 0 days come out or when new CVEs are introduced, we're able to very quickly ensure that all sensors that are deployed across any environment have the up-to-date patches if necessary, and certainly have constant curating by our security operations team to make sure those patches are always up to date. So I know this is a lot of information. We're super excited about this as we continue to roll this out. Short, little blurb as a teaser more than anything else to get you guys excited about what we're rolling out, to try to get some more interest as we dive into RSA and the follow-on services we're going to do here. As I said, again, what I'm most excited is that this brings a whole nother layer of protection to ThreatX in order for us to be able to bring additional capabilities. And I don't mean to say that we didn't protect against runtime attacks in the past, but what I will say is this allows us to do it at much faster speed, much more accurately, and provide a lot more information to be able to justify and validate and provide our customers the satisfaction that they know the thresholds are set properly, providing protection without false positives. This gives us the ability for us to do something in an out-of-band scenario for those requirements that require that. I will say most of the feedback with the customers that we're working with on a pre-GA release, the feedback has been this is fantastic as an additive solution. So utilizing reverse proxy for edge protection, and then using this to really deploy across their Linux environments to give both an added layer of protection, but also kind of the backdoor protection, as I mentioned earlier. Again, east-west, something that you can do with reverse proxies, but more difficult to deploy. This greatly simplifies that. And at the end of the day, this is something that, we're super excited just because of the capabilities and the fact that it's extending not just capabilities, but it sticks to our main core themes that we have at ThreatX, which is ease of use, high value add, quick time to market, all in a very enterprise-worthy package, but something that doesn't create the operational burden on the side of our customers as well. So good. Any other questions from you, Sid? Or if not, I'd love to not just talk at people and show a bunch of PowerPoint slides, but actually open it up for some Q&A and just have some discussion from anyone who has questions about what we talked about.
Yeah, beautifully put. And again, thank you, Brett, for walking through everything. We actually do have some questions popping up in the chat now. Please, for everybody else who is on with us, feel free to pop a question in the chat. We'll be sure to cover that in some of the time that we have remaining with Brett. But one of the questions that we have that just popped up is, Brett, you talked a lot about Linux and Kubernetes for runtime API and app protection. Is there going to be any support for legacy Microsoft web apps that are not cloud-based?
Yeah, and I think that's, partially you still have some runtime protection, certainly even within the reverse proxy. But the cool thing about eBPF is that the capabilities that it provides, there are so many different, vendor categories that are interested. It can be folks that are looking at it for optimizing performance. Certainly, there's numerous observability solutions that are out there, and then security is a no-brainer for this. So what you're seeing is that there's an eBPF framework that's out there for virtually all of the major cloud organizations that are out there, public cloud organizations that are out there. Obviously, standard Kubernetes deployment, and Microsoft also fits into that category as well. So you can kind of cover the full gamut of any of the major cloud providers. Now, I think the key to that question was legacy. And I think, to a certain degree, that's really going to depend on a couple of different factors. For those legacy applications, it may make more sense for us to look at the reverse proxy to sit on front of those while still deploying the RAAP-based sensor deeper in the stack, especially for things like the APIs that application may be utilizing as well. So again, we see this as a potential for certain circumstances where it could replace the reverse proxy, but in most cases, reverse proxy is still going to give you a lot of added benefits out at the very edge. It's going to give you a lot of added benefits for legacy applications, maybe acquisitions, and the ability to quickly get something under protection within minutes, but also adding this as a deeper layer in the stack, and especially for those integrations, like I said, around APIs or other kind of components like that. Great.
Perfect. Thank you so much for that first question. And again, folks, keep them coming in. We'll of course prioritize audience questions first and foremost as they pop up in the chat. But the next one that recently came up is, how is ThreatX ensuring that the kernel isn't at risk with this new eBPF technology being deployed really at the kernel level?
Yeah, that's a great question, and I blew through that pretty quickly as I walked through that. But that's what we love most about the eBPF framework. And having said that, there's a vast difference between what used to be custom kernel modules and how they interacted with the kernel versus the eBPF as a framework and as an API that really provides a lot of the protections for the kernel. Now, there are limitations even to the size of the application or the size of the sensor container that you can create to be able to interact with the API. So you have certain limitations in just how much you can actually develop, which are purpose built to make sure that you're not overextending or overtaxing the sensor itself. There are other things though that are going to be much more around how you actually develop those technologies. And I think that it's going to be one of those things that we have been very careful to look at exactly each and every integration opportunity or integration point that you can have with the kernel via the eBPF framework. In which of those components does it make sense for us maybe to integrate? Let's say we could integrate at the socket layer, or let's say that we could integrate one layer below, but we've chosen actually to take the base data and ensure that we can take that base data, parse it, and actually process it in a much more high performant fashion and still have access to as much, or in some cases more data than we would have had by integrating simply at the socket layer itself. So I think that's what's super cool about, I think, the framework itself is it does provide a sandbox environment. It does provide a lot of protections for the kernel. And to the extent that, when you're actually bringing up the environment, it will go through the validation process. And if it doesn't fit the validation requirements, then it drops the sensor altogether. So it's definitely something that is partially addressed by the framework itself. And then, as I said, I think what we've really been keying in as we've gone through our analysis is how do we take advantage of, lower levels of the OSI stack to gather as much information as we can, do some of the processing that we need to do at that level to get even better performance. But we're already talking about super high performance when you're talking about integration at the kernel speeds already. So I think it's a protection side and it's a performance and scalability side that we're really trying to take into effect here.
Perfect. More questions flowing in from the chat. Love the conversation that's being stirred up, everybody. Would this be categorized under endpoint detection and response tasks from
Great question. So, and this is the teaser portion of this conversation for us. So we're not here to compete with CrowdStrike. We're not here to compete with some of the other kind of endpoint solutions. We're not even here to compete necessarily with any of the container security solutions that are out there at this point in time. We are an application and API protection company. And so we've really focused, at least this release, 100% on deploying and making this very easy to deploy in a containerized environment, most certainly, but focusing in on the types of attacks that you see specifically against applications and APIs. And I say that because, hey, there's, as a founder of a company or as a technologist, I'd love to have the one ring that rules them all. But we have to stay very focused in terms of where we're at today and what we're doing. I think I can only allude to the fact that with the information that we're seeing, we're certainly seeing lots of opportunities for expansion. But I want to be very clear that what we're announcing here at RSA, very much focused on taking our bread and butter, which is protection of applications and APIs, extending this capability for these run type of attacks, and really, again, trying to adhere to the pillars that have made this company very successful, which is always going to be about making it as easy as possible for our customers, giving them the white glove treatment from our security operations team, but really providing those insights and observations that make them feel like they know they're getting the quality out of the platform itself.
Perfect.
And then the answer is, I think I could see us going in certain directions, but it's not what we're here to talk about today by any stretch of the imagination. So.
Perfect. Thanks so much for walking us through that, Brett. And I appreciate the subtle Lord of the Rings reference, by the way. I saw you snuck that in. Perfect. Last question, I think, for our time remaining today. And again, thank you so much for the audience engagement. Does the sensor sidecar container image have multi-architecture support?
Depends on your definition of multi-architecture. So I may or may not fully understand the question, at least as it was intended there. But I would say from a cloud and from a Kubernetes architecture perspective, we started with the obvious things like the standard Kubernetes deployments, GKA, AKE or AKS. So the Google components for deployment, AWS deployments, and Azure deployments are the first ones, and those will come in what we're announcing right now is support for each of those. We've also we typically will integrate it at least in our prototyping and with our first pre-GA customers. We've used Istio kind of for the orchestration components of that as well. So again, depending on multiple architecture or multiple environment where you were going with the question, I would say, yes, our support will cover all of the major cloud offerings and the various varieties of each of those offerings as well. So.
Perfect. And I'll sneak one more question in. I think this is a really great question. Thank you so much, Ben. I was wondering what the process of vetting, choosing a new technology was like with eBPF. I guess, Brett, could you speak to some of the internal work that was done when creating Runtime API and app protection?
Well, I think, eBPF, I think any software company is always looking at new technologies as they're rolling out. eBPF isn't that new. It's actually been out for quite a while now. A number of companies have addressed various aspects of whether it's network monitoring or other observability components with eBPF. So I think we evaluated it from the sense that it's a complex technology. It's not something that every company could do or can do well, maybe is the best way to say it. But it is a technology that certainly has shown a lot of promise, has a lot of successful case studies that are out already. And then like anything else, we have a very sharp set of engineering resources here at ThreatX that we wanted to kind of turn loose for some of the R&D work, skunkworks level activities that they were doing. And I think as we kind of went through it, we set some very aggressive timelines to say, here's 30-day goals. Let's see if we can adapt it to do X. Can we now adapt it to do Y? And for us, we're very conscious of not just producing a solution that is going to be a monitoring or observability tool, because we know that generates too much alerts, too many additional capabilities. We wanted something that we knew that we could also leverage the eBPF capability to invoke blocking along with it as well. And so I think as we started to see each of those milestones get achieved and good progress made, that's when we started to get super excited. And specifically with the type of data that we were seeing, as well as some of the red team kind of testing we were doing against it for the various attack types that we know are out there. So, you know, this is going to be the tip of the iceberg, I think, for us. This first release, obviously, will just be a great sensor capability that we're able to add to the market, but it will continue to grow, obviously, as will the application behind it, to be able to leverage the type of data that we're seeing here. So I don't know if that fully answered the question, but it certainly isn't lightly that we dove into it, but it certainly fits very well with the model and with the way that we approach identifying attacks, really building as much contextual information as we can around those particular attacks, and it's just fit in that, you know, hand in glove. So.
Perfect. Well,
Great.
I think that concludes our co-founder Q&A. So Brett, thank you so much for hopping on and answering some of the audience questions. We really appreciate it.
Great. Well, I enjoyed it. I'm looking forward to seeing everybody at RSA, and looking forward to future announcements that we do around this. So.
Speaking of, we wanted to say anybody whose answers we did not, or questions we did not answer, we'll be sure to follow up with that next after the session. And again, for those who are joining and interested in our ThreatX hacker hoodies, we'll be sure to send out follow-ups for the winners for those after the event today. So again, just wanted to say thank you everybody for joining the event. Make sure to check out ThreatX if you're going to be traveling out to RSA. We have lots of exciting events happening, not just the Runtime product announcement, which you can also see all of the supporting resources. Here we are on this page. Monday night of RSA, we're doing a book signing with Bruce Schneier for his new book, A Hacker's Mind. Also, alongside, we have book signings and demos with ThreatX. Featured the author, Nick Alex, who recently published his book, Black Hat GraphQL. So like Brett mentioned, come visit ThreatX at booth 4103, as we have tons of exciting things going on at the ThreatX booth located in South Moscone Hall. So again, thank you everybody for the time today. We hope to see you out in San Francisco.
Great. Thank you.